Hello everyone, I am Dr. John. In this section, I will ask few questions from you for your self-assessment. So, let's get started. As we have studied that, in the graph at the bottom, the yellow line represents the concentration in compartment 1, and the green line represents the concentration in compartment 2. Note that at time C, glucose concentration is 10 mmol per liter in both compartments. At that time, diffusion equilibrium has been reached. Now my question is that, imagine that at time C, additional glucose could be added to compartment 1, such that its concentration was instantly increased to 15 mmol per liter. What would the graph look like following time C? Draw the new graph on the figure and indicate the glucose concentrations in compartments 1 and 2 at diffusion equilibrium. Are you able to draw? Let's draw it together. There would be a net flux of glucose from compartment 1 to the compartment 2, with diffusion equilibrium occurring at 12.5 mmol per liter. Moving towards our next question. You learned that proteins have several levels of structure. So my question is that, which levels of structures are evident in the drawing of the ion channel in this figure? Are you confused? Well, let me help you. The primary structure of the protein is represented by the beads, which is the amino acid sequence shown in A. The secondary structure includes all the helical regions in the lipid bilayer, shown in A. The tertiary structure is the folded conformation shown in B. The quaternary structure is the association of the 5 subunit polypeptides into one protein, shown in C. Moving towards third question. What might determine the value for maximal flux of a mediated transport system? Are you able to answer? Well, let me clear you. Maximal flux depends on the number of transporter molecules in the membrane and their inherent rate of conformational change when binding solute. If we assume that the rate of conformational change stays constant, then the greater the number of transporters, the greater the maximal flux that can occur. Moving towards last question. Draw pathways by which substances cross membranes. Let's draw them together. This is the pathway showing direction of net solute flux crossing a membrane by simple diffusion, means from high to low concentration. This is the pathway showing direction of net solute flux crossing a membrane by facilitated diffusion, means from high to low concentration, through transported molecules. While this is the pathway showing direction of net solute flux crossing a membrane by active transport, means from low to high concentration, through transporter molecules. This was all about today's video.
Explore our extensive library of over 1,800 video lectures to learn about a wide range of topics. Only on sqadia.com.